All right, guys, we're taking it up a notch today. We're going to do a little live notes on the board just to make sure that for the past couple of days, everything that we've been doing, we're all on the same page with. We've gotten the same type of stuff out of it. So what we've been talking about for the last couple of weeks are the different spheres. And this is getting us ready to go into climate change. We've been told that we're not supposed to do a ton of new teaching, so that's why this might seem easy to you or review of things that you learned in middle school. But we're just trying to all get on the same page so that when we can actually start doing real teaching and teaching you guys about different stuff, we're all on the same page about the spheres. So the 4 spheres that we've talked about and that there are on planet Earth, there are 4 spheres. Everything is within one of those spheres. So the first one is the geosphere. Don't know if you guys can read that or not. The second one is the biosphere. It's green. The third one is the hydrosphere. And then the fourth one is the atmosphere, which I don't know what color to use for that. I'll go with orange, like the sunset. All right, so these are our 4 spheres. Everything on the planet is within one of these 4 spheres. And hopefully what you've been noticing is that these spheres are all connected. If something happens in one sphere, it is very likely going to influence one of the other spheres and lead to these chain reactions that keep intersecting and influencing all the different spheres. All right, so the first one, the geosphere, is one that we've really covered a lot. That's pretty much what we did during quarter 3, talking about rocks, minerals, plate tectonics, mountains, trenches, things like that. That's all part of the geosphere. Basically, you can think of it as the non-living, essentially hard stuff. So it would be the non-living, and you can generalize it to be the hard stuff. So examples, like I just said, plate tectonics, rocks, minerals, gems, sand, mountains, valleys, any shape of the land, riverbeds. Those are the things that are in the geosphere. They're solid, they're hard, they're non-living. One that a lot of people didn't point out was metals. Remember that metals come from the geosphere, so your car would have part of the geosphere in it as well. Okay, so the next one is the biosphere. So unlike the geosphere where nothing's living, the biosphere is where everything in the biosphere is living. So that would be living things. So that would be animals, including humans, plants, bacterias, animals that live in the ocean, plants that live in the ocean, algae, anything that's living belongs in the biosphere. The hydrosphere, hydro, if you know your etymology, hydro means water. There's my little water droplet. So beautiful. So the hydrosphere is anywhere that there's water. So that would be lakes, rivers, oceans, puddles, streams, glaciers, water reservoirs, the underground water, especially if you have a well, there's actually water underground that you are sucking out of the ground to get your water. All of those things are in the hydrosphere. So anything dealing with water belongs in the hydrosphere. And then the last one is the atmosphere. It's a little tricky because we can't see it, but it is all around us right here. And it's basically just the gases that are in the atmosphere that don't belong in any of these spheres. Now, a lot of times we think of the atmosphere as having things in it, like birds or airplanes. And yes, those things are flying through the atmosphere, but they aren't necessarily a part of the atmosphere themselves. The atmosphere is really just the gases. And in a couple days, we're going to talk about which gases are in our atmosphere, but nitrogen and oxygen are the two big ones. Other things that we think about being in the atmosphere that kind of bridge different spheres. So it's not like a hard line. Sometimes things can be in different in like two different spheres. So things like clouds. I saw it on your sphere sheet that a lot of you were saying clouds were in the atmosphere, which they totally are. That's not wrong, but they are also obviously a part of the hydrosphere because they came from water. Dust is also in the atmosphere. Dust isn't a gas itself. It's probably part of the biosphere or the geosphere, depending on what kind of dust it is. So those are things that we also think about being in the atmosphere. But you should feel comfortable at this point with geosphere, biosphere, hydrosphere, and atmosphere. So we've talked about this one a lot in class. So I'm going to put a check mark next to that. We should be good with that. Rock cycle, how things move, weathering, erosion, that's all part of the geosphere. The biosphere, if you're taking bio this year, biology is pretty much all about the biosphere. So you're good on that. And if you aren't in bio this year, you'll get it next year. So I'm checking this off because you will have a whole entire class on that. These are the two, the hydrosphere and the atmosphere, that we are going to be talking about for the rest of the year. And before we talk about how all of these are connected and related and deal with climate change, we need to learn a little bit more about the hydrosphere itself and a little bit more about the atmosphere itself. And then we can put them all together. So we're going to start by talking mostly about the hydrosphere. And the next few days, we're going to do some water labs and learn about what is special about water. So we're going to focus on hydrosphere, then we're going to move to atmosphere, and then we're going to combine the two and start talking about weather and things like that. Then eventually we'll get to climate. So that's kind of our plan for the next couple weeks. So if we're looking at just the hydrosphere, we can start looking at all these different pieces of it. So like I just said a second ago, hydro, that word, just like we talked about how geo means rock, sub means under, hydro means water. So if you ever see the word hydro in front of something, has something to do with water. So first we have to talk about where all this water came from. That should pretty much be review for you. Can you use your brain and think about where all this water came from? So if you remember back to when we were talking about the beginning of Earth in the Hadean era, we talked about how the theory, which is generally accepted, is that the water came in on comets and meteorites as the accretion was happening onto the planet. So it came from comets, comets and meteorites during accretion. And I mentioned in a piece of writing earlier that accretion and the runaway feedback, where things are joining on, and getting bigger and bigger, that is an example of a positive feedback loop, because something happens and that causes more, that causes more, that causes more. So that's a really great example of a positive feedback loop. So we know the hydrosphere is all the water, and we know that it came from comets and meteorites during the beginning of planet Earth. And all of that water is constantly recycled. So this is getting into the water cycle, which is another thing you probably have talked about, but we'll go in a little bit more depth to make sure that you're at the 9th grade understanding of the water cycle. So the basis of the hydrosphere is water, and here on Earth, we have 3 phases of water. So we have the liquid form of water. We have the solid form, ice. Ooh, there's a little water in there, ice. And then we have the vapor form. There is water that's in the atmosphere and the air around you. That's what humidity is. So on really hot days when it feels really sticky outside, that sticky is just water that's in the air around you. So that's what humidity is. So here on Earth, we have 3 phases of water. We have the vapor form, the liquid form, and the solid form in ice. That is special here on Earth. On other planets, we don't have these 3 different phases. It's only here on Earth. And that's called, or the area that we live in is called the Goldilocks zone. Goldilocks zone. The Goldilocks zone is this area in space, in our solar system. It's this one sliver where if you are in this sliver, you can have all 3 phases, liquid, vapor, and solid. If you get further out into the solar system, like towards Mars, Jupiter, Saturn, then it gets too cold to have the liquid and the vapor form. And if you get closer to the sun, it gets too hot and everything evaporates away. So we live in this perfect Goldilocks zone. So obviously, if you think about the story Goldilocks and the 3 bears, you know, you have the mama and the papa bear, that it's always too hot or too hard of a bed or too big. And then the mom's is too soft or too small. But the baby bears is just right. So that's exactly where Earth is. We are in an area in space that is just right to have these 3 different phases of water. And it's those phases that make life possible here on Earth. Holy cow, would you look at that? My board changed. All right, so water has a lot of really important characteristics, and learning more about water and why it is so special chemically is something that you're going to learn about when you get to chemistry. Things about how it's polar, what it's made out of, that it's a universal solvent, all this stuff you'll learn about in chemistry. We're not going to bore you with it right now. What I want you to learn about is how water affects temperatures, weather patterns, and all the stuff that we're going to be talking about in these next few weeks. So today, I'm going to introduce one of water's really important characteristics, and that is that it has a high specific heat, is what it is called, a specific heat. Okay, so specific heat is something that in high school and in college, I really didn't understand, because everyone told me the real definition of what specific heat is, which if I look at my notes, the real definition is how much energy it takes to raise a substance 1 degree. depending on what you're working with, sometimes they're talking about Kelvin or they're talking about Celsius. So I can't really say which degree it is because it depends on what you're working on. But basically, this was the definition that they always told me. Oh, the specific heat is the amount of energy it takes to rise a substance 1 degree, which doesn't make a whole lot of sense to me. Surprise! So, like I was saying yesterday, um, specific heat never made a whole lot of sense to me because everyone always just told me the definition of it, that it was the amount of energy it took to raise a substance up a degree. So today we're actually going to do a little lab where you get to explore what it means to raise a temperature up a couple degrees. This is something that I really would like to do in class because usually I do this activity where we are heating something up and we can see how much energy it actually takes to raise water up a degree or how much energy it takes to raise sand up 1 degree. So normally I do it with water and sand by heating it up. But today, because you guys might not have sand at home, I don't, and you may not have a way to heat things up safely, and your parents might not want you using the kitchen, we are going to do it the opposite way. So we're actually going to be cooling stuff down. So if there are some directions that I spent a while writing, so I hope they are clear. If you have trouble with it, let me know. But you should find the directions for this specific heat lab in Google Classroom. So if you go there, you should see it. If you have any questions, let me know. And good luck. I hope you understand what specific heat is a little bit more than I did in high school. Bye. Just kidding. You can't go yet. If you have any feedback for how this went for you, let me know. So I'm trying to figure out ways to make the learning accessible and to make it so that it's not too overwhelming for you guys as we go into this online learning stuff. So if you have feedback for me for things that have worked so far, how this video worked, or anything that's going well in your other classes that you think I should do, send me an email so that I can make this class better for you guys. Okay, now go to the lab.